While most people believe that electric vehicle battery innovation is mainly about achieving faster charging times and extending driving range, Tesla seems to have unveiled an entirely different breakthrough, one that centers not on how quickly energy enters the battery, but how rapidly and powerfully it can be discharged. In early 2025, confidential documents from a covert Tesla research facility leaked details of a project called Quantum Pulse, involving a new aluminum-ion battery system capable of delivering a stunning 7,000 watts per kilogram. That's roughly 10 times the energy output of conventional lithium-ion batteries, and it's achieved without the usual downsides. This new battery doesn't suffer from power fade, avoids heat-induced throttling, and is structured around a crystalline lattice that actually performs best at temperatures as high as 85 degrees Celsius. It also holds its output across more than 10,000 discharge cycles. Imagine a Tesla Model 2, priced around $15,759, not only keeping pace with a Porsche in acceleration, but also charging up to 80% in just 5 minutes, all without any minerals. Sourced from China, that's not a theory. That's a complete transformation that could disrupt China's $400 billion battery dominance. Historically, the industry has focused on improving how fast EVs can be recharged. But Tesla's engineers approached the problem from a different angle. They recognized that the real bottleneck isn't in absorbing energy, it's in releasing it when it's needed most. What happens when you slam your foot on the accelerator? Should feel like liftoff. Tesla's new aluminum-ion cells make that sensation real through Quantum Pulse, a delivery method that sends power in microbursts rather than through a constant, high-drain stream. It's a method designed for efficiency and performance without degrading the battery. Compare this with Tesla's current high-performance Model S Plaid. On paper, it boasts over 1,000 horsepower, but that impressive stat only lasts a couple of seconds before internal battery temperatures rise, triggering a safety mechanism that cuts power by up to 40%. This is a result of lithium's inherent limitations: dendrite formation, electrolyte breakdown, and structural fatigue, all of which worsen with repeated high-power use. In contrast, aluminum-ion cells used in quantum pulse configurations avoid dendrite buildup entirely. Their internal structures actually strengthen under stress. Instead of declining with each cycle, they thrive on usage. Performance test results show this isn't just theoretical. Tesla's aluminum-ion batteries, thanks to their microburst architecture, sustain a stunning level of output that lithium simply can't match. A compact Model 2 can now rocket from 0 to 60 miles per hour in 3.2 seconds, beating many legacy sports cars while still being accessible to average buyers. It's not only about raw power, either. These batteries function at their best under extreme conditions, remaining stable and potent even in the hottest summer temperatures. They don't need to be cooled down like lithium batteries, which begin losing output once they hit certain heat thresholds. Tesla also layered in adaptive power scaling, making their battery pack intelligent enough to adjust energy flow based on the car's surroundings and use, where older battery systems dump power uniformly, regardless of context. The aluminum-ion system adjusts to city traffic, highway cruising, or sudden torque demands, improving energy efficiency by up to 15%. Whether you're navigating traffic or hauling a 5,000-pound trailer up a steep incline, the power delivery remains smooth and robust. Even when temperatures hit 90 degrees Fahrenheit, tests show these new packs retain 95% of their efficiency. Under the same conditions, lithium packs can drop by as much as 30%. Tesla demonstrated that the aluminum-ion pack can handle 15 consecutive hard launches using Ludicrous Mode with zero degradation. Lap after lap of track driving without power, throttling, and even heavy-duty towing up steep grades without experiencing dips in performance. These packs can release energy at levels that would be unthinkable for today's lithium batteries, up to 2 megawatts instantly. That's equivalent to the energy used by 200 homes or an industrial-grade welding rig running for hours. Regenerative braking performance also receives a boost, with 98% of kinetic energy being recaptured during deceleration. Hills, instead of draining your range, now recharge it. Tesla's achievement isn't just about braking performance, it's about changing the very experience of driving. The aluminum-ion Model 2 feels almost alive, responding intuitively to your driving inputs. It's fast, smart, and refreshingly simple. Even skeptics would be stunned to witness it in action. As for charging, what used to be the Achilles heel of EVs, Tesla may have just shattered the last psychological barrier. With this new battery chemistry, enabled by a feature called hypercharged nanolattice, Tesla's batteries can charge up to 80% in only 5 minutes. That's faster than most people take to make a cup of coffee or wait in line at a gas station. This is no longer some distant dream. It's the result of aluminum ions moving through cell structures at speeds 10 times faster than lithium ions. In a real-world setting, that means plugging in at a Tesla supercharger and driving away in less time than it takes for a typical playlist to get through one song. A 2025 survey revealed that a majority of gasoline car owners would consider switching to EVs if charging took less than 10 minutes. Tesla has delivered a solution that meets that demand. And it's not just about how fast it charges, it's about reliability across climates. The hypercharge lattice design sheds heat rapidly, meaning charging performance isn't reduced in extreme temperatures. Whether you're parked under the sun in Arizona or shivering in a Minnesota blizzard, charging time remains consistent. This directly challenges China's current EV offerings. Take the XPeng G9, for example, one of the fastest charging EVs from China. It still takes 18 minutes to reach a similar charge level. That's impressive until you compare it to Tesla's 5-minute result. The difference is enough to shift global market share. Experts believe that this new battery tech could erode China's EV dominance by as much as 30% by 2030. Vision doesn't stop at improving battery performance and charging times. The company is overhauling the entire production and supply system behind these batteries. Leaked blueprints reveal the next generation of Gigafactory, smaller, more efficient, and staggeringly productive. The new Gigafactory 2.0 design produces 10 times the battery packs of existing facilities, yet takes up just a third of the space. Automation runs 97% of the production process, with only minimal human intervention for quality control. Tesla is already scaling rapidly, with a dozen such facilities scheduled to launch in 2025, followed by another 35 in 2026. By 2027, Tesla expects to have over 100 such plants worldwide, and that's just the beginning. A parallel plan known internally as the battery swarm would see the deployment of compact, micro-gigafactories in 20 countries. By 2027, each of these smaller factories would have the capacity to produce 1 million battery packs per year. The result is a colossal drop in production costs. Aluminum-ion batteries made this way are expected to cost around $40 per kilowatt hour, less than half the current cost of lithium batteries. This would slash the price of a model by 25%, bringing high-performance EVs into the reach of a much wider audience. These factories also tap into abundant materials. Aluminum is not only cheaper and more common than lithium, but facilities can recycle 95% of battery components on site, further lowering environmental and logistical costs. All of this removes the need for Chinese rare earth materials and sidesteps their refining monopoly. In raw numbers, Tesla could save more than $10 billion annually by 2030 through this supply chain independence alone. And the same battery cells aren't just going into cars. Tesla is building a scalable energy infrastructure using the same aluminum-ion tech for residential power walls and industrial megapacks. By 2028, this could allow Tesla to provide up to 5% of global electricity needs. The distribution plan is just as innovative. Imagine ordering a Tesla Model 2 and receiving it within 72 hours anywhere on Earth. Thanks to a tightly integrated delivery network run by Gigafactory Express, Tesla semis handle last-mile delivery, and you can pick from nearly 850 million configuration options. Tesla is even floating new ownership models. Pay just $8,000 upfront and lease the battery for $99 per month, or buy the full package for under $16,000 and upgrade to the latest battery annually. What makes this all the more disruptive is how deeply it contrasts with competitors. While Chinese battery firms are stuck in large, centralized systems with rigid supply chains, Tesla is building something modular, flexible, and powered by artificial intelligence. Experts predict that Tesla's decentralized approach could completely destabilize China's $100 billion battery industry. This isn't just about beating rivals, it's about completely shifting the landscape of transportation, energy, and global trade. Tesla's Model 2 and its revolutionary battery tech aren't just steps forward, they're redefining what electric vehicles can be, with blistering speed, ultra-fast charging, and unmatched affordability. This isn't just another car launch, it's a shift in global transportation. The quantum pulse system signals a future where performance and sustainability go hand in hand, accessible to everyone. While others talk innovation, Tesla is delivering it faster, cheaper, and on a scale never seen before.